In a world where nothing is what it seems. Sometimes, you just need to take a step back and take a second look. Discover the weird, quaint, and downright bizarre. It's time to rethink.
Color changing milk. Here's a fun and easy trick that you can try at home. It's even safe for kids. It's calming, colorful, and well, it's also a good demonstration of the liquid properties of milk, coloring, and soap. Science! If you're up to it, then let's go. But first, you will need a shallow water container like a plate or a shallow bowl, some full cream milk for different kinds of food color, some cotton swabs, dishwashing liquid, and maybe have a camera handy to cover the action as it takes place. To prepare, first set up in a well-lit area. Place your container in a clean flat surface. Now, pour some milk just enough to cover the surface of the container. Remember, it doesn't have to be filled up completely. We will be doing multiple trials, so conserve the milk. Now, take your food coloring and randomly place a few drops of each color over the milk. Now prepare your dishwashing liquid. Dip a cotton swab, not too much though. You want it to be just the right amount, so go ahead and shake off and wipe the excess soap. It should be enough to not be able to drip. Now for the moment of truth. You may want to hit record on your camera now. Dip the cotton swab in the middle of the milk and watch as the colors dance and create all sorts of swirls and effects. Now, you may want to experiment some more with color placement. So throw the old batch and prepare a new one. Don't worry, it's safe to be disposed of in the sink. Try it some more and see what interesting shapes and patterns you can come up with. So why does the color spread like that in milk, you ask? Well, it's all because of a property of liquids called surface tension. You see, liquids have a property that allows it to have a thin film made up of its molecules. This allows very light objects to rest over that film. Say for example, a strand of hair or another liquid just like in the experiment. Milk contains a mixture of fats, proteins, and even water as part of its components. The fats in milk have a non-polar and hydrophobic property or water-repelling property. But when soap is introduced, the surface tension of the fats in milk is broken and moves away from the soap. As the polar hydrophilic or water-attracting components of milk react. The result is the milk-fat component separating. And because we have food coloring on the surface, you can see how this phenomena occurs. You can see it in action with a slow motion of the footage. This seemingly invisible phenomena has its practical application as well. Actually, it's how soaps and detergents help us remove stains and help clean out stuff when rinsed with water. Soap breaks water surface tension, making oils, stains, and even small debris slide easier when rinsed. Chroma Key. It's no secret. Most movies, especially those involving action scenes, almost always utilize computer motion graphics. And while we already know that computers are responsible for big backgrounds, monsters, and explosions, there is still one technique that movie makers use to make it all come together, with the actors that are playing on screen. So have you ever heard of Chroma Key? Well, maybe you've seen it in a few behind-the-scenes footage. Remember the large green screen where actors stand in front of? Yeah, that's it. But it's not just the screen. It is a technique in itself. So, what is chroma keying? It's the technique used to make certain parts of a video keyed out or made transparent. This is done by shooting objects in front of a green screen. The green color is then processed out of the film, essentially erasing the background, leaving a clear blank slate. This allows movie makers to insert any footage or background that they wish. For the most basic example of chroma keying, you can check out your local weather forecast. Notice how the weather anchor's background is always a map, displayed with a few weather patterns. Well, now you know how it's done. Now you might think that chroma keying is relatively a new invention in the field of motion pictures. But that's where you're wrong. The technique has been in existence since the 1930s. First as a method to create wiping transitions or matte wipes, as developed by visual effects pioneer Lynwood G Dunn. The technology then developed in full use in 1958, as used in the movie The Old Man and the Sea. The first types of chroma key effects utilized a blue screen. That's before people began using green as a background. Now why green, you ask? This type of green is determined to be as far from human skin tone as possible, and most of the props in a film shoot. Imagine, if you were wearing something blue, then part of your body will become transparent as well. Still, for green objects and clothing, sometimes blue and other colors are used. In the older times, the blue background is processed out of the film using a special chemical that develops the blue color into a clear colorless background in the actual film roll. The movie makers then use another roll of pre-shot footage of whatever scene or background that they wish to apply, combining the two films together and then projected on a fresh roll of film. The result is complete background replacement for the film. Nowadays, everything is done in software, with the help of computers, but the same concepts apply. The green background from digital footage is keyed out in the computer and is replaced with a different background. You can even do it at home with a computer or even your phone. First, make sure you have the correct software or app to use. Don't worry, these are cheap, and sometimes you can even get them for free. Next, you will need some green material for your background. Large sheets of green paper or green cloth will do the trick. Now go ahead and shoot your subject in front of the green screen. Remember to shoot it in a well-lit area. Now, when you're done, run your app or software and select the green part of the footage. The software should take care of keying it out, with just a few adjustments. When you're satisfied with the result, go ahead and replace the background with anything that you want. Get creative and see what scenes you can come up with. And voila! Instant video magic. Math mentalism. So, did you hate math when you were a student? Well, don't worry. This won't be hard or even boring. So what if we told you that you can use math to perform some cool mentalism and prediction tricks? Cool? Okay. Well, check out the following tricks. Let's start off with this one. Announce that you will make a prediction and write it down on a piece of paper. Ask someone to pick any number from 1 to 5. Then multiply the result by 9. Then add the digits of the resulting number. Now ask them to subtract 5 from that number. And tell them to replace that number with a letter from the alphabet. That's 1 for A, 2 for B, 3 for C, and so on. Now, if they did the math, they should end up with D. Now ask them to name a country that starts with D. Then tell them to use the last letter of their chosen country to name an animal that starts with that letter. And lastly, ask them to name a color using the last letter of the previous word. Now after that, you show the prediction to the audience. Sure enough, it's Denmark for the country, kangaroo for the animal, and finally, orange for the color. Now these answers are the most common. So if you ask a volunteer quick enough, they're most likely gonna answer these. But that's just half of the trick. The other trick lies in the first part with math. See, anyone's number you multiply by 9 will yield a 2-digit number that has digits that add up to 9. Then once you subtract 5, you'll always end up with 4, which corresponds to D. And then, well, you know how the rest goes. Neat, huh? Here's another one. This time you will need a book. You'll also need a calculator. Here's a little preparation on the book. Turn to page 9 and memorize the 9th word. And then turn to page 108 and memorize the 9th word as well. They will be used for the trick. Ask the volunteer to select any 3-digit number with no repeating digits. Then ask them to reverse the digits and subtract the smaller number from the bigger number. If the answer is 198, then you are almost done. Tell them to add the reverse of 198, and you'll get 1089. Now ask them to turn the dictionary to page 108, the first 3 digits of the number, and tell them to count 9 words down, as in 9, the last digit of 1089, and then tell your prediction. The 9th word from page 108, which you already memorized. Now, if you get a different answer, say 99, then just proceed with the trick and tell them to turn to page 9 and pick the 9th word that you memorized. Now, if you still get a different answer like 297, 396, 495, or their inverses, continue subtracting the inverse of these numbers until you arrive at 99, and then proceed with the trick. Say it with conviction and some good old-fashioned acting, and you'll be amazing people in no time. The secret to both tricks is actually utilizing the unique property of math and numbers to make people arrive at predictable answers. And from there, it's just a matter of making them believe that you have arrived at their seemingly random number, further reinforcing the trick. Leaden frost effect. So you think you're pretty familiar with water? Well, it's not like you drink it every day or use it for cooking and washing things, right? It's not like 2/3 of the planet is made up of it too. And we're pretty sure you're familiar with water droplets too, like when it rains and you see it on windows, right? Sure. Well, here's a refresher. Water is a compound molecule made up of 2 hydrogen atoms and an oxygen atom. That's H2O, or dihydrogen monoxide if you want to get technical. Water mostly exists in a liquid state, but it evaporates into vapor or its gas state once it boils at 100 degrees Celsius, and then turn into solid or ice when the temperature hits 0 degrees Celsius. So consider this experiment. A hot metal plate hotter than 100 degrees Celsius, or the boiling point of water. So what do you think would happen? Well, let's find out. If the surface is hotter than the boiling point, you'd expect that water would instantly evaporate as it hits the plate. But what's this? It's like droplets are actually forming and sliding in the hot plate. Is there something wrong with the water? Why don't the droplets evaporate on contact? Well, it can be explained by what is known as the Leaden frost effect. The effect is named after Johann Gottlob Leidenfrost, the scientist responsible for discovering the effect. It's the physical phenomenon where liquids that come into contact with a mass that is hotter than its boiling point produces a thin insulating layer of vapor. This thin layer is what actually keeps the droplet intact for a period of time. And since this layer is in a gas state, the droplets don't actually come into direct contact, but rather slide around over the hot surface. If you take a closer look, this effect can be observed oftentimes when cooking. In an extreme demonstration of the effect, a wet finger was dipped in molten lead, allowing the finger to be insulated and protected from burning for a short period of time. It goes without saying that you shouldn't try it at home. But here's an experiment that's safer for you to try out. You may want to wear insulated gloves or mittens for this one. You'll be needing a frying pan, a medicine dropper, and of course a stove. If you're a minor, seek adult supervision for the trick. You want to start with just a small flame over the pan, and just go ahead and place a few drops of water. At the first trials, the water will form droplets and then start to boil, then turn into steam or vapor. Keep the stove on and increase the fire a bit. By this time, the pan should be hot enough and the water droplets should vaporize on contact. Try it out. But remember to be careful and keep your face and other body parts away from the top of the pan. Now increase the flame to its highest and give it a few seconds. Now drop some water in the pan and observe. You should see tiny droplets slide and even bounce around the pan. If you listen closely, it sounds like small beads hitting the metal pan. Here, check it out. If you have steady hands, you can try placing drops beside each other and even forming shapes. Watch as the droplets form a bigger mass, then slowly start to shrink and then eventually evaporate.
Now, this episode would not be complete without a quick discussion on some notable rethinkers. People who are responsible for giving us these mind-boggling illusions and tricks. Today's featured rethinker is Lynwood G Dunn. If you love watching movies, then you ought to know Lynwood G Dunn. He is a celebrated visual effects pioneer and inventor responsible for most of the techniques and effects used in filming motion pictures. He was born in 1904 in Brooklyn, New York. Dunn had his start working as a projectionist in Hollywood around 1923. This is where he had his training in the filmmaking business, then eventually landing a job as a cameraman. In 1928, Dunn started working on automating transition effects like wipes and fades, which previously was done manually by cinematographers. He eventually devised a technique and successfully reconfigured an optical projector to achieve automated transitions. Big-budget films of the era were filmed with Dunn on the helm for visual effects. His famous works include Citizen Kane and King Kong. Around the 50s and 60s, Dunn founded his own company and even developed and marketed his own designed optical printer, the machine responsible for processing blue screen shoots or chroma keyed shoots. This allowed films to insert different backgrounds and objects in films, which paved the way for modern filmmaking techniques. This was also the time where he would start working on Star Trek, which is one of the most popular sci-fi shows of all time. Dunn would go on and spend the rest of his career as one of Hollywood's visual effects consultants. Dunn's work has won him many awards and recognitions. He retired in 1985 and settled into his North Hollywood home until his death in 1998.
Well, it's the end of the line for this episode. But don't worry, there will be more. Be sure to tune in next time for more tricks and illusions, as we give you another mind-boggling dose of Rethink.